then the question will become hard. It will not stay medium anymore. Let's see what the problem says. The problem says that we are given the root of a binary tree. Now again, the first fact is that it is a binary tree. A binary tree is having 2 nodes, 0 nodes or 1 nodes at max, and it's a tree, which means it's not a graph. Remember, it's a tree. And also you are given the root. Okay, in a tree usually you are given a root itself, and it's of unique values. But what is the significance of unique values? So basically you will be given an integer called as start. So for sure, if the tree would not have unique values, then you would have said, okay, start can be 2 nodes also. So it is specifically mentioned. And again, this is a clarification question which you have to ask in an interview. So in interview will just say, okay, you are given a binary tree, you are having variable start. So now you have to ask him, is the tree having unique values? If not, then you can have multiple start nodes in the same tree itself. So this is the thing which you have to make sure that you have to ask the interviewer. Okay, great. Now at the minute 0, an infection starts off from the node with a start value, and it will keep on propagating to the neighbor values as we simply propagate. And if you had remember what is the propagation algorithm, just comment down below, pause the video and comment down below, okay, what is the propagation algorithm which you know right now. Okay, and it just says, okay, whatsoever node is not affected, it will get infected, and it will just try to infect the neighbor nodes. And we have to return the minimum, we have to return the number of minutes needed, like number of minutes needed for the entire tree to be infected. So let's say we had this 3 node infected. So at time 1, my node 1, node 10 and node 6 will be infected. Now at time 2, the neighbors of node 1, which would have been node 5, although node 3 is also a neighbor, but yeah, it is already infected, so no worries, not thought to mention. For node 10, the neighbors are nothing. Okay, great. For node 6, neighbors are nothing. So after 2 minutes, my 5 is infected. Okay, great. Then in 3 minutes, 5 will infect its neighbors. In next minute, 4 will infect its neighbors. And that's how in 4 minutes you can simply get this solved. Okay, so basically in 4 minutes I can infect everyone. So answer is 4. Now, as simple as that, as I initially mentioned, that it's a propagation. So from 3 you will start off and going on to the neighbors, shortest distance or nearest neighbors you will go to and will infect them, and then again from them go to the nearest neighbor and then infect them. If you had not figured out the algorithm so far, the algorithm is simple, a BFS, breadth first search. Breadth wise you search for something. So but bhaiya, we saw that, okay, I will simply do a breadth first search from node 3 and I will try to find the maximum. Basically I just do a breadth first search, and as I go on to the next level, so what I can do is I can imagine this tree as a 3, 10, 6, 1, and this 1 will have a 5, will have a 4, will have a 9, and will have a 2. So I can simply start off my BFS from here. Okay, here I will go, and then here I'll go, and then here, and then here, and then here. That is one thing which I can think of doing. But you remembered, it's so in a graph you would have simply started off with this node 3 and you would have completed that BFS. But it's a tree. So if I am at 3 node, I can go to 10 and 6. I cannot go to its parent, which is 1. That is an issue. Oh, bhaiya, okay, parent I can store only. But what if I ask you, okay, if it had, let's say, a parent 8, a parent 9, then what? Let's say 9, like 9 is already there. Let's say a parent 7. So how would have you gone to the parents? So like either you have to store all the parents first and then go on, or rather I'll say, why not convert this tree to a graph? So what you will do is you will just convert this tree itself, which is the tree itself, as you saw that you had a tree given, you will convert this tree to a graph. Now simply how to convert the tree to a graph? It's just that you know that you have a directional edge. So I know that, okay, for node 1, see, graph is nothing but saying, okay, everything is undirectional. So I know the node is 1. I need to just assign, and see how we represent graph as an adjacency list. One node in a list of all of its neighbors. So I know node 1 has the neighbors as node 5 and node 3. So in the adjacency list of 1, I'll simply push 5 and 3. And then I'll recursively call, okay, bro, make the graph for node 5 and node 3. So he will go, okay, he will try to make the graph for node 5. Node 5, and for sure, as I'm coming on from my parent, so I would know, okay, at least I would know my parent. I might not know my parent's parent, but at least I would know my parent itself. So I can store and give him, okay, parent is 1, which means you are coming from your parent, and this is your child. So for node 5, I know, okay, I can just push back its parent, and I can push back its child, which is 4. And the same way for 3, I can push back its parent, which is 1, and then I can push back its child, which is this 6 and 10, and then I can again propagate downwards. Okay, again call the recursive function and make the graph, and that's how I can simply do a recursion, which means my graph is being built by recursion itself. And then when the graph is built, then I can simply apply a BFS algorithm. So firstly, we used DFS to build the graph. DFS is a simple recursion to build the graph, and then when DFS is done, which means my graph is built, I will use BFS to actually go on and do the shortest path, obviously the maximum distance which I can actually get. As in the distance is simply propagate all nodes, and then all nodes, and then all nodes, and then if you reach the end, that is the distance which you have got is the actual distance which you will need to cover the entire graph. So you will see that first basic thing, as you know that our graph is an adjacency list, right? So which is, okay, a node to all of its neighbors, a node to all of its neighbors. So I basically initialized basically I said, okay, I will use a graph, which means I will make an adjacency list by myself. So I just call this function called as convert, which will convert this tree having a root. The parent is 0. Bhaiya, what about 0? Okay, 0 is a parent. So you can put any default value which is not in the scope of the solution. So if you go back, you will see that node values are from 1 to 1e5. So out of this scope, you can put any values. Okay, great. So this is my parent, this is my root node, which is basically a tree, and that's my graph which I want to actually build off. So I'll pass this by address, and this is for sure I'll pass. Now I'll come on to my convert function. It's as simple as I showed you, that if a simple base case whatsoever we have, that if something is null, then simply return from here. Now I actually want to build my graph. So as I showed you above also, that let's imagine that I am on this node, this pink node. I have got information from my parent, I know my child. So I'll just say, okay, firstly I just get the address value. So basically let's say the node value is a 2. So for 2, whatsoever adjacency list it will be making, which means it's a vector, it's an unordered map of integers to a vector. So I know that it's a vector. So I just want to push in 2's vector, just push in its neighbors, which can be anything. It can be 1, 3, and 4. Right. So I have to push in 1, 3, and 4, where 1 is the parent, 3 is the left child, and 4 is the right child. So I just need to push these things. So I'll just simply say, okay, have it by address. Now the address thing is just only useful so that I don't have to write this entire thing. I don't have to write the graph node value again and again. I just know that, okay, in this list portion, I just have to push back the neighbors. So first thing is I'll push back the parent, but if you remembered, by default I passed in a 0 value as for the root. So I just have to make sure, okay, for the root, by default its parent is 0, but it's not an actual node. So I just have to make sure, okay, I should not use 0 itself. So if my parent is not 0, then you can simply push back your parent. Then you will try to push back your left child. Okay, again, left child is not null, then you will push back the left child's value. If the right child is not null, then you will push back the right child's value. When all my parent, left child, right child is done, parent, left child, right child, and that's the maximum thing. For a tree, for a binary tree, that's the maximum number of node for one node which you can have, the neighbors which you can have. And then when this is done, I'll simply call and say, okay, bro, now try to build the graph for your left child and for the right child the same way. Okay, I'll just try to build the graph from my left child, again passing me as the node, and again for the right child passing me as the node. And that's how I can simply build my graph out of my tree. Now, when this portion is done, which means my graph is now built, now comes the interesting part. Now I have to do the BFS starting from the start node. From this node, I will try to do the BFS. Okay, how I'll do? I'll simply know that in a BFS, you just push back the first node in the queue itself. So I'll push back my first start node in the queue. Now when the start node is fixed, I need to figure out the number of minutes needed, which means at every level of my BFS traversal, I'll simply increase the number of minutes. Okay, that's great. And then this is to make sure that I visit every node exactly once, right? because it's a graph now, it's not a tree. So you might be able to go to the parent, but you don't want to go to the parent again and again, so you'll just keep the visited because it's a tree. Sorry, it's a graph. It's a graph now, not a tree. Now a simple BFS traversal that while q is not empty, size is equal to q dot size. Now in the yesterday's videos, many of the people were asking, Bhaiya, why you were actually writing this size. So see, in BFS traversal, in a simple traversal, you can also do it without size. But when you have to traverse level by level, which means you have to make sure that, okay, firstly the next level should complete and then I have to go to next level, then you have to put in like this. So by default, anyway, if I have to traverse like this only in a BFS traversal, so I have to traverse level by level, I always use this. It's a safe path to actually go by sizes, which means right now what's the size of the queue, which means it is the size of my current level, and that's how I can simply propagate. Okay, great. Now I'll simply go and say, okay, what's the current node, which means, okay, it's a queue, a simple BFS, it's a queue. What's the front node of the queue? That's I will just simply get. I'll go on to all of its child. If that child is not visited, just simply visit that child and push back in the queue, and that's how I will traverse that specific one level. Now when this level is done, I'll increase my minutes. Now bhaiya, okay, that is like short because for one level it takes, okay, 1 minute, one level for 1 minute. But why did you do it -1? Because if you remembered, if let's say I make of this tree right now, so what will happen, I'll just say for this first, as this level is done, it will increase the minute to 1. So now my minute will become 1, minute will become 2, 3, 4, 5. Minutes became 5 because it has kind of 5 levels. But my answer was a 4. If you remember, my answer was a 4 because it is how we propagated. So it is just that, okay, I was having a +1, so I just can simply do a -1 because I'm just doing it. Also if you don't want to do it, so you can initialize it will be -1 also. That also will work. But yeah, simply we can just get this minutes as minute -1. Now that is the time will be actually O of n, but specifically if we go down, it will be O of n plus n, which means O of n to actually build the graph out of a tree, and O of n next to do a BFS traversal on that tree. And for sure, a space of O of n will be used for making a queue, visited, graph, and all that stuff. So graph and all that stuff will be used for a space of O of n. Now that is okay. In a program, in a contest, it's okay. The time and space is okay. But in an interview, the interviewer will ask you, can you please optimize it? Which means that he will ask you to optimize time. But time is O of n. We can't do it in O of log n or something, which means I have to go on to every node so as to find the distance. For sure, I have to go on to every node. Every node means I have to get the time as O of n. But if you saw here, I was using O of n plus O of n. So can we do it in O of n time only? Just one pass. So now we will see how we can do it in one pass. Now, to do it in one pass, we should know one thing. Okay, our ultimate aim is the distance, or basically the depth. So if I know this node, I should know, okay, consider this node, 3 node as the root node. Now, if I consider the 3 node as the root node, so I would know, okay, the distance to its left child, the distance to its right child, and whatsoever is the maximum distance or the maximum depth, that will be my answer. Okay, but again, maximum depth, if you would have asked me for a graph, which means if I would have said, okay, it's a root node, okay, it's a, where it is gone, it's a root node, so maximum depth I would have easily found out if it's a graph. But it's a tree, and converting the tree to a graph was the thing which was taking us the O of n time, extra time, and that is what I cannot do right now. I have to think of something else that while computing, maybe I can figure out the answer. So now you have figured out, okay, what's your ultimate aim? Your ultimate aim is to just figure out the maximum depth starting from that node, which can, again, that's a tricky part which you have to figure out. Because if let's say I would have said, okay, if 1 is the start node, which means from 1 you have to just figure out the maximum depth, right? So you would have gone and simple do a DFS traversal. You would have gone to the left, you would have gone to the right, you would have gone to the left, and you would have asked him, bro, your depth is 1, your depth is 1. Okay, I'll take the maximum of both of them, okay, -2, which means maximum of left depth, right depth +1. Okay, I'll give him, okay, left depth is 0, right depth is 2 +1, my depth is 3. Again, for him, Left depth is 3, right depth is, if you just go back and again do a DFS here, so he will get a 1 1, he'll get a 2, he will give him a 2, he will give him a 3, he'll take the maximum and he will get a maximum is 3 plus 1, which is 4. So for him the maximum depth is, as you can see, 4, right? That is okay, that is for 1 the maximum depth is 4. So for 1 I would have known him, I would have, and bhaiya, why is this maximum depth needed? So if you just simply see that maximum depth is okay, how far is the farthest node? How far is the farthest node for me? And that is what I wanted, and that's a time which I would be taking if I would traverse like this. Okay, so for node 1 it was very easy. I just can simply do a DFS traversal to all the nodes because it's very simple. But for 3, how will you do a DFS traversal? Which means from 3 you cannot go to 1, 5, 4 like this, you cannot go. But bhaiya, now if I know the parent, then again I can go to the parent, and then from parent I can again simply go down. Okay, that's again true. But what if I just say you, okay, your parent, you're above, let's say for 1 your parent is 8 and then your parent is 7, then again you have to go to the parent and mark who all are parents of who all, which means for 1 I will mark my parent as 8, for 8 I will mark my parents as 7. This all I have to keep on marking, which will again is kind of saying that I'll try to build a tree, I'll try to build a graph out of my tree. That's again the same O of n time. So what we have seen is if normal thing would have been there, which means if 1 would have been my root node, so I would just ask, okay, maximum of left depth and right depth plus 1 would be correct depth of mine, and that will be my maximum distance also. But it is not the case now. What is the case now? Your case now is, okay, your start node is a 3. So what I'll do is I'll apply some hack. What's the hack like? So I just wanted, okay, I just tried to do a simple DFS traversal to get the simple depth, but then I just have to make sure, okay, if in my if in any of my subtree I encounter a start node, then I have to strategically think of something else. So what I'll do is my relation between, okay, let's say for sure it's a root node, so I will start my DFS traversal, which means a simple to find the depth. I'll start from here itself. But for him everything will be different. For him left subtree is a normal subtree. For him left subtree is a normal subtree. How normal subtree? As you can see, for it is the same node, right? It is the same node, one node. For him the left subtree is a normal subtree. As a normal subtree it is, but the right subtree is not a normal subtree. Right subtree is having a start node. So for the start node itself, okay, so right, it is not normal. And how it is not normal? Because right contains start. So I know that, okay, if my any subtree contains start, I have to treat that differently. Okay, I know one thing, as I have to treat my subtree containing a right containing start node as I'll treat that as a different node. For this node 3, again, this is a normal subtree. This is a normal subtree. If it would have been again more nodes, so it would have been a normal subtree for node 3. For node 1, again, it is not a normal subtree. Now, okay, I know one thing, okay, I can treat this as a normal subtree. So when I say I can treat this, which means I can simply do a simple traversal, which means maximum of left plus right and plus 1. So what I'll do is I can simply go and ask, bro, can you please go and bring me the left depth? I just want the left depth from him, and it's a normal part, so I can get the left depth easily. So I'll just simply go and do a recursive call. 5 will go and call 4, 4 will go and call 9. 9 will just simply go and call its childs, which are null. So for sure, I have a base case. If my node is a null, then I'll simply return a 0. So he will return a 0, which means 9's left child because it's a null. He will return a 0 because 9's right child is also null. Null 0 plus 0 maximum. Okay, I want the maximum depth. So 0 plus 0, 0 maximum of 0, 0 plus 1 will be the depth of 9. And the same way, I'll go and get the depth of 2. Again, he will go and get the depth of 4, which is maximum of left depth, right depth plus 1. Okay, it's a 4 depth. It's a depth of 2. Again, node 5 will get a depth of 3. As you can see, again, this you saw maximum of left depth, right depth plus 1. Now, my simple node 5 will get maximum from left, right. Maximum left depth is actually a 0, right depth is actually a 2. As you can see, right depth is 2, left depth is 0. So for sure, for him, depth is maximum of left depth, right depth plus 1. And that's how my answer is. Okay, it's 3. Now I can simply return my 3. That is the normal case because it was a normal subtree not containing my start node. So I can treat that normally and I can apply the same formula for him. Right now, bhaiya, what is this if conditions? We'll see that, but just remember, it's a normal subtree. It's a normal subtree. How I treat that as a normal subtree, just to show, okay, it is not containing my start nodes. But bhaiya, what if it contains? Which means, as I'll just do my recursive call on the right side, okay, as you saw that I did a recursive call on the left side. So I will have a recursive function which will just do a solve function for the left, which means solve for the root left. It will solve for the root left, and then again a solve function which will solve for the root right. Again, now when I'm reached the root right, again for him, okay, again it will, in a DFS you just go in the depth. So for 3 it will go and do a DFS on the left and on the right. For sure, again for 3 its subtree is normal, so I can treat this as a normal part. Okay, it's a normal, so he will be treated as a normal part. He will also be treated as a normal part because its subtree are not containing the start nodes. So it's a normal. So when something is normal, you just simply treat them normally. Okay, its distance will become 1. It will become 1. Now comes the interesting part. Now when they will try to return to the parent, so the parent is not normal. The parent is actually a start node. So this is not normal. Again, although right now I have not even returned from this subtree itself, it will also be abnormal. But currently, right now, I am on the start node, which is not normal. So what could have been the case? What could have been the case? I want to find the maximum depth. So in the worst to worst case, what could have been the worst case? Either your maximum depth would have been on the left side, which means on this. Just imagine this as the 3 as the start node, as the center node. So this is the left side, right? Or you can say the right side, and this is the left side. So I just want the maximum depth from the right side and the maximum depth from the left side. Whosoever is the maximum depth will actually be my answer, or the maximum distance for me. So coming on back, I know this is a start node. So I need to get the maximum distance in this left side. I'm not seeing the maximum depth, I'm seeing the maximum distance, which is the final answer which I want to return. So I'll say maximum distance will be nothing but whosoever is giving me, okay, either the left depth or the right depth, whosoever is maximum, that will actually encounter me and give me the maximum distance. So here the maximum distance is maximum of left depth comma right depth. Again, that is not the depth itself, it's a bhaiya, but you used to say na, the depth is maximum of left and right plus 1. But bhaiya, why you did not do a plus 1 here? Because it's a maximum depth. Now it just simply says one thing to me, that okay, as you can see, maximum here also the depth is 1, here it is also 1. So you might not understand this, so I just increase that. Let's say I added a 8, so its depth will become a 2, right? So now if I ask you, maximum distance between left and right is actually will be a 2. So although its depth you can write it as its depth, you can write it as a 3, but I'm saying the maximum distance for 3 on this left portion, because again it's a left portion for him and the right portion is above portion for him. So for the down portion for him, the maximum distance is maximum of left and right. So the maximum distance will actually become a 2. And that's also true, because if you imagine that this would not even have been there, so this is the maximum distance, or the maximum the depth, or basically the if you remembered in the question you were asking minutes, so that minute will be here it will have 1 minute, here it will have 2 minutes. So that is a 2 minute which you would have got. So that is how you can simply get or compute the maximum distance when you are at the start nodes. So we remember one fact, that if we are at the start nodes, we will have to compute the maximum distance. So if my root value is a start, I will have to compute the maximum distance. Just saying that the right portion or the down portion of my subtree can also contribute to the maximum distance. Okay, that is great. But is it enough? I still have my upper subtree. What about that upper subtree? So for sure, if I have my upper subtree, I have to make sure I have to return something to him so that he should add value to my answer. So I know, and again, remember, I have to bifurcate. I have to just imagine something as, okay, left was not having my root node, right was having my root, or like right was having my start node. So I should treat my right differently. Now to treat that differently, what I'll do is I will give him, although you will see that your distance would have been, by the standard logic, your distance would have been a maximum of left and right plus 1. It would have been a 2. But I'm saying if it is my root node, I will return a -1 to my parent. I'll not return my actual distance, which is the maximum of left and right plus 1. I'll return a -1. Depth is -1 to my parent. So I'll return a -1 to my parent. But bhaiya, why? Let's see why. So what will happen is, okay, this was computed. It will return a 3 as a depth. Like left depth is 3. Right depth is -1. Now, for him, it will also be treated as differently. Now, because its subtree is now containing a start node. Its subtree is now containing a start node. But bhaiya, how did we know it? We get to know it because either the left distance or the left depth is less than 0, or the right depth would have been less than 0. If anything is less than 0, it will indicate that, okay, for that less than 0 portion, I would have a start node. That is the reason I just put in a -1. Just to show, okay, that will represent, if something is less than 0, it will represent that is actually a start node for me. Now, bhaiya, that makes sense. Okay, so what I can do right now is that I'll know that it will return a 3, it will return a -1. What is the distance for me? So I know one thing, okay, 3 will just indicate, okay, 1, 2 and 3. It is the minutes for this right part. -1 is indicating this distance. So I would know, okay, 3 plus 1 will be the distance from this 3 to actually last node. So, okay, I will have to convert it to an absolute value. So whatsoever number is negative, convert that to absolute. So I would have to write an if else condition. So I converted both of them to absolute. Okay, absolute of left distance plus absolute of right distance, and then get the answer. So, bhaiya, why you converted both of them? As I spoke earlier, you have to write either if condition. Whosoever is negative, convert that to a positive and get the answer. Else, you can just convert both of them to positive because one is already positive, so it will be actually positive. So now it will be 3 plus 1. So it will just say, if I will be start computing the answer from 1. So 1, okay, at 1, I know that, okay, left distance is less than 0 or right distance is less than 0. That is the reason, if you remember, I just applied this condition, left depth, right depth, both are more than equal to 0, then only I just apply this formula of depth as this. Else, I will not apply that same formula. So if this is a condition, which means if any one of them is less than 0, then I'll firstly have to update my maximum distance. It is the answer. It is not the depth. It is not the depth. It is the answer itself. So I'll update the maximum distance. It will be nothing but whosoever. Okay, my maximum distance will be 3 plus 1. So it will be saying, okay, it is a 4. So answer is 4. Maximum distance 4. But again, I have to update my depth also, because right now his parent is nothing. But what if his parent would have been there? So let's say his parent would have been 8 here. So he should return something to his parent. So what he will do is, he had got a -1 from here, 3 from here. Now he knows that my subtree has a start node. So he will have to monitor that start node and take that start node as a first preference. So he will just get this -1 as a distance, and he will add a -1 again in that and get a -2. Now bhaiya, why -1 added? Because if you remembered, I took a condition as left distance is less than 0 and right distance less than 0. So I want to make sure it is negative. But I also at the same time want to make sure that my distance is increasing. So you will see that from node 8 to node 3, my distance is actually a 2. So I want to make sure that my distance is increasing. I want to make sure that it should also contain the fact that I have my start node in that portion of my subtree. So this negative will indicate that I have a start node in this part of the subtree, and this 2 will indicate the distance from this 8 to actually a 3. Now bhaiya, but if you said that okay, if left distance is less than 0 or the right distance less than 0, then you update the answer or the maximum distance itself. So what's the maximum distance now? So if I imagine that for 8, it will, from the left portion, it will get a -2. From right, it will get a simple, let's say by imagining I made a big subtree on the right side of 8, and he will return a distance of 8 itself. Let's imagine. So for sure, its maximum distance will actually become absolute value of left plus right. So left is 2, which is absolute of -2 is 2, and right is actually 8, which is 8 here itself. It will become a 10. That will simply show me, okay, from 3, if I go to 8 and then this is the entire portion, so that will be the distance. That can be the maximum distance. Again, that can be. It's the reason I'm maximizing my maximum distance itself. Okay, that can be my maximum distance. That's the reason I am updating at every of those values whose left distance less than 0 or right distance less than 0. I'll update my maximum value. And that's how I can update that for all the answers. So you remember one thing, that okay, I'll update, if I have got any of my childs as if I have got any of my left distance or right distance as negative, I will have to add a -1 in them. So okay, I'll add a -1 in them. So negative number -1 I have to add. So I can just simply take the minimum of left and right distance and add a -1. Remember, either one of them will be negative. So again, in this I could have written a if condition. If LD is negative, then add a LD -1, or RD is negative, then add a RD -1 and then assign to my actual D. But I just say, okay, take the minimum. Minimum will always be negative. So for sure, I'll add a -1 in the negative number itself. So that will always be negative. So which means if here I see, okay, 3, -1, take the minimum. It is a -1. Add a -1 in that. It will become -2. So that will be my answer. Again, for here 8, I'll simply say, okay, minimum from left and right, -2 or 8. Again, minimum is -2. Add a -1 will become a 3, -3, and I'll simply propagate that. So that's the reason. To make the code shorter, I am using a minimum of left distance and right distance. And that's how I will have this else condition in the code, where I will find this distance, which is again the absolute of left and right depth. As you remember, it is absolute of left depth and right depth, and then update my maximum distance with this distance itself. And that's how I can simply, and after updating this maximum distance, I can update my depth also, which is this depth, which I have to get and propagate to my parent, which is minimum of left depth and right depth -1. So these three conditions, his condition right here, the condition when I am at the start node, and the condition when I am of no worries, like my left or right child is not containing my start node. These three conditions are the only condition which I need to make sure I have to write. That is the reason his question, if we try to use this, it actually becomes hard, because it is not at all easy in an interview to come up to such a complex great solution, and that too in a very less time. So now we'll go on. Again, I consider this DFS portion to actually be hard because it's actually hard. Now coming on back, I'll simply initialize. It's a simple recursion or simple DFS, that you have your maximum distance as a global variable, which is the answer which you want to get. If you remembered, I'll simply traverse starting from the root, and that's a start node. Just to remember, okay, what node is a start node, because start node plays a very crucial role in our algorithm. I'll ultimately this traverse will actually update this global variable, and I can simply return that global variable. Now comes the most interesting part. Firstly, very basic case, that if something is done, return a 0. I'll go and try for the left depth. I'll go and try for the right depth. Simple recursion. Now, when I have the left and the right depth, now I can simply apply my operation. How my operation will look like? If both the left and the right depth are more than equal to 0, then simply update or simply say, okay, maximum of left and right plus 1 will be my depth. But okay, if that's not the case, if my root value is the start value, then simply say that the maximum distance, you will update the maximum distance, because you know that start node is here. Its subtree can also give you the maximum distance. So you will update its subtree's maximum distance by saying, okay, maximum distance is maximum of left or right. And also to bifurcate, or basically to say, okay, now I am having my start node in my subtree itself, simply start returning my depth as -1. So you'll see I'll return my depth as -1 if I've encountered my start node. Now when these two portions are done, condition comes in, okay, if you are encountering any of your left depth or right depth as a negative number, which means it is not positive, which means any one of them would be negative, so for sure update your maximum distance with absolute value of the left depth plus right depth. And then when you have got this, you can update and give the depth as negative number -1. And that's how you will simply propagate this depth to the parent. Minus indicates that I am having a start node in my subtree, and depth of that portion minus of depth of that portion indicates that's a distance from the start node to me, to the current node. So that's how you can simply get this solved, again in a simple O of n time and O of n space. O of n space is got the recursive stack because it's a recursion, right? So for sure in this Q tree, it will actually be all nodes. So my stack, or basically the recursive stack, will contain all the nodes, and that's how you can simply solve it in O of n time and O of n space. Again, that's a very tricky question to come up with. I don't think that if you get this and if the interviewer asks you, you should be able to do it. But if you now know it, then you should be able to come up with it. So thank you so much for watching. Bye bye.